vehicle hardware is built to support multiple missions with minimal refurbishment in between. And while this Dragon has flown once before, the booster that we're flying today is actually brand new, so after stage separation today, we'll be bringing that first stage back to our drone ship, Of Course I Still Love You, so that it can be flown on future missions. Now, it was just a few weeks ago that we launched our second Falcon Heavy mission and successfully landed its center core on Of Course I Still Love You, as well as its two side boosters on Landing Zone 1 and Landing Zone 2. But today, the drone ship will be positioned much closer to land, approximately 12 nautical miles off the coast of Cape Canaveral, versus the 535 nautical miles for that Falcon Heavy mission. Since we're not going to geosynchronous transfer orbit for today's mission, we have enough performance to complete a boost back burn and ultimately land closer to shore. And the closer that we land to shore, the easier the weather forecasting is, and the chances of recovery for that booster increase. Our launch window this morning is instantaneous, which means we only have 1 second to launch Dragon. So if for any reason we need to stand down from today's launch attempt, we do not yet have a backup date, but we are working with NASA and the range to launch on the earliest date possible. It's about T-minus 10 minutes, and the SpaceX team is working no significant issues. The go, no-go poll was conducted at T-minus 38 minutes, and propellant loading began shortly after that at T-minus 35 minutes. The SpaceX team has completed loading fuel onto Stage 2 and is nearing the completion of Stage 1 fuel load, which should finish up around T-minus 6 minutes. LUX load is underway on both Stage 1 and Stage 2 and will wrap up in the last few minutes of the countdown. And we're also loading helium gas into storage vessels on both stages. We use the helium gas to pressurize the tanks as the propellant is pulled out by the engine pumps. Dragon is also getting ready. It began its auto sequence at T-minus 35 minutes, and that's when it coordinates timing with Falcon 9 and makes sure that all of its systems are healthy. The next big step for Dragon is to move to internal power at T-minus 8 minutes, which was coming up here in just about a minute. The range is ready to support. Airspace and sea surface are clear for launch. Checking in on the weather, we do have a 70% chance of good weather. We are looking out for some thick cloud layers and a little bit of precipitation, but it's still looking good for us at T-minus 0. So with Falcon 9, Dragon, and the range reporting green at T-minus 8 minutes and counting, all systems are go. Our Dragon spacecraft has been making trips to the space station for 7 years now, and today it's still the only vehicle flying that can deliver significant cargo both to and from the orbiting lab. In 2010, SpaceX became the first private company to send a spacecraft to orbit and return it back to Earth. 2 years later, in 2012, Dragon became the first privately developed spacecraft to visit the space station. And since then, SpaceX has made a total of 18 trips to the station, and we're currently under contract with NASA for a total of 26 cargo resupply missions. Dragon will be carrying dozens of research payloads to the space station, including the research in the National Laboratory, operated by the Center for Advancement of Science in Space, or CASIS. There are more than 20 payloads included in this mission sponsored by the National Lab. The National Lab payloads represent a diverse group of research investigations, all which are intended to benefit life here on Earth. Let's take a look at some of the groundbreaking research from CASIS that will be aboard the CRS-17 mission today.
The International Space Station U.S. National Laboratory has a variety of payloads that are packed and ready to launch aboard SpaceX's 17th resupply mission to the International Space Station. Many of those payloads represent life science investigations, all with the intention of improving patient care back on Earth. Let's get an idea about some of those investigations that are associated with this mission. The ISS National Lab is partnered with a branch of the National Institutes of Health that is providing funding to support the use of tissue chip technology for research on board the space station to benefit human health on Earth. 4 of these tissue chips in space investigations are launching on this mission. Tissue chips, small chips containing human cells grown on an artificial scaffold to model the structure and function of human tissue, enable better disease modeling and higher accuracy drug screening. In microgravity, human tissue chip models have the potential to accelerate pathways for understanding the mechanisms behind disease and developing new treatments. Pharmaceutical company AstraZeneca is sending the first of multiple investigations to the ISS National Lab to improve patient care on Earth. This project seeks to advance a novel drug delivery system that uses nanoparticles as carriers for drugs to provide targeted and controlled release therapies. Specifically, the research team will evaluate a proprietary method of nanoparticle formation in microgravity toward improved drug formulations that have greater efficacy and are easier for patients to tolerate. This mission also includes multiple protein crystal growth investigations. In microgravity, crystals often grow larger and with more uniformity on the ground. High-quality crystals provide a more detailed understanding of protein structures, which enables improved structure-based drug design. One protein crystal growth payload from the National Cancer Institute's Chemical Biology Consortium aims to conduct multiple protein crystallization experiments on the space station aimed at drug discovery. The goal is to develop an accelerated drug discovery pipeline that takes advantage of macromolecular crystallization in microgravity. While we highlighted some of the life science research investigations that are part of this mission, the ISS National Lab is driving research initiatives through all walks of scientific life. From physical and material sciences, technology development, in-orbit manufacturing, small satellites, and much more. To get a better idea about the full breadth of research that's happening on the ISS National Lab, visit issnationallab.org and go Dragon.
This is just a small sample of the dozens of research experiments that Dragon will take up to the space station. You can follow at space_station on Twitter for more information on the exciting microgravity research happening on the station. We are at T-minus 4.5 minutes and continuing to count down for our instantaneous launch window. In these last few minutes, the Falcon 9 is performing final checkouts to make sure all primary systems will work in flight. Those checkouts include propulsion, communications, and avionics systems. As I mentioned earlier, fuel and liquid oxygen valves are open for loading up the propellant tanks. We do prep the engines prior to flight, so cold liquid oxygen chills in the turbo pump on each of the 9 Merlin engines on the first stage. This is what we call engine chill, and that began a few minutes ago at T-minus 7 minutes, and you might hear the call out for the engines being sufficiently chilled later on in the countdown. Checkouts of the second stage thrust vector control actuators are now underway. We perform a test called engine wiggle. This is when we move the thrust chamber slightly to make sure the guidance hardware is go for launch. First stage engines wiggle just seconds before ignition. At T-minus 1 minute, Falcon 9 flight computers will enter startup mode and guide the rocket through the rest of the countdown. And the SpaceX launch director gives the go for launch at T-minus 45 seconds. Finally, just in the last couple seconds before liftoff, the engines are ignited, and at T-minus 0, the rocket is released from the hold-down clamps. At liftoff, the strong back retracts away from the rocket, clearing the way for the launch pad. And Dragon is also performing its own final checkouts to make sure all of its primary systems will work in flight over the 3 days that it's going to take to rendezvous with the space station. Range is go for launch. The weather is still looking good, so let's listen into the nets during the last few minutes of the terminal countdown.
fuselage loads closing out. Falcon 9 is on internal power. Falcon 9 is in startup. Dragon is in startup.
Ground gas closeouts complete.
Stage 2 pressing for flight.
Go for launch.
T-minus 30 seconds.
Stage 1 pressing.
T-minus 15 seconds.
Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 0. Ignition. Liftoff. Air Dragon go Falcon.
Vehicle is pushing downrange.
Stage 1 Airship AOS.
Power and telemetry are nominal.
Vehicle is supersonic. Vehicle is experiencing maximum aerodynamic pressure.
It's just after T plus 1 minute, and we have had a nominal liftoff of our Falcon 9. We're just about to pass through max Q, which is the maximum aerodynamic pressure that the vehicle will see. Actually, we've confirmed that we've passed through max Q. So now we will have a series of 3 events coming up in rapid succession: main engine cutoff, stage separation, and second engine start. Main engine cutoff, or what we like to call MECO, is where all 9 engines on the Falcon 9 first stage shut down. This is then followed up by the stage separation, or the separation of the first and second stages. And then finally is the second engine start, where the Merlin vacuum engine on the second stage lights up and begins to carry Dragon to its targeted orbit. So let's listen into the countdown net for those 3 events coming up here in just about 10 seconds.
MECO.
Stage separation confirmed.
Stage 1, we're going to report.
Now there you can see on your left screen is the first stage, and on your right screen is the second stage. We've just had a successful MECO and stage separation, as well as second stage startup, which you can see on your right screen. That's the second stage engine glowing red there. We've also begun the boost back burn for the first stage. That you can see brightly on your screen, on your left screen there. And there on your right screen, you can actually see the nose cone from Dragon deploying and falling back down to Earth. Now that nose cone helps protect the Dragon during ascent from aerodynamic loads, but once we're in the vacuum of space, we no longer actually need it.
And stage 1 boost back burn shut down.
And as you see on your left screen, it has gone dark because the boost back burn is now complete. And in order to make its way back to the drone ship of Course I Still Love You, the first stage executes a series of 3 burns. The first burn is the boost back burn, which you just saw, and that's meant to slow the rocket down and reorient it for re-entry. Shortly after this first burn is initiated, the grid fins, which are located near the top of the first stage, are deployed to help guide the rocket during descent. Following that boost back burn, Falcon 9 then executes its re-entry burn, which slows itself down before hitting the dense parts of the Earth's atmosphere. Then last is the landing burn, which helps to rapidly slow down the first stage booster as it touches down on our drone ship. It's T plus 4.5 minutes here, and the second stage is on its way to drop Dragon off into its targeted orbit. What you see on your screen there is that nice glowing Merlin vacuum engine. We've had an on-time launch this morning at 2:48 a.m., which was just a few minutes ago, and ascent was nominal. We've had a great stage separation. And now second stage is on its way to take Dragon to orbit. So coming up here in about 1.5 minutes will be that entry burn that I mentioned earlier for the first stage. If we do land this booster today, it will be SpaceX's 39th booster landing. Now it's very early in the morning here, so we don't get a lot of sunlight in that first stage view. But when we do have the entry burn start, you should be able to see a little bit of that first stage.
Stage 2 continues to follow a nominal trajectory.
T plus 6 minutes, and we're just about 30 seconds away from that first stage entry burn. Second stage is still looking good.
Stage 1
And there you can see on your left screen there that first stage re-entry burn has just begun. It's glowing pretty bright there.
Stage 2 continues to follow a nominal
So we're not getting a lot of sunlight, at least the engines are giving us a good view of that first stage. Now we actually don't need all 9 engines for this entry burn, so we are actually only using 3 engines. And that completes the first stage entry burn.
Stage 1 FTS is saved.
Now the first stage landing burn should be beginning in about 20 seconds here. It's a bit dark, so we might not be able to get a great view of the first stage landing, but we'll see what we can see there. And it looks like we got an infrared shot of stage 1 there. That's an awesome view. So we're not getting a lot of sunlight, at least we could see it with the infrared view. And there's that landing burn beginning. That looks awesome. Again, we are landing on our drone ship, Of Course I Still Love You. Looks like we're following the first stage all the way to the drone ship.
Terminal guidance.
Looks like we've got a good live view of this landing here. And we have touchdown of the first stage, Falcon 9 vehicle on our drone ship, Of Course I Still Love You. That was an incredible view of that entire landing. That was awesome. So now going back to our primary mission, our second stage is about to meet. Actually, it looks like we just had SECO, the second engine cutoff, which means we're coming up on Dragon separation soon here. Waiting for confirmation of good orbit. And we have confirmation of good orbit. And we've got this live view of the Dragon trunk from the second stage, the aft end of, or the forward end of the second stage. And we're looking directly into the trunk of the Dragon. So inside of the trunk of the Dragon, what you can see there is some of these science experiments that Dragon is taking up to the International Space Station.
Acquisition of signal, Newfoundland.
And there you can see on your screen, Dragon has deployed. And again, that is such a cool view of these science experiments in the trunk of that Dragon.
Dragon separation has been confirmed.
As mentioned previously, Dragon is carrying tons of cargo to the International Space Station on this mission. A small portion of that cargo represents supplies for the astronauts, which is things like food and clothing, but most of that cargo represents science going up to the space station. The International Space Station serves as the world's leading laboratory where researchers conduct cutting-edge research and technology development that will enable human and robotic exploration of destinations beyond low Earth orbit, including Mars. So what we have coming up next in about a minute and a half is the solar array deployment for Dragon. And if you could see in this view, the solar arrays are actually folded up against the side of Dragon. So what will happen during deployment is they will actually extend out almost like an accordion. And that'll be around T plus 12 minutes. So we're just about a minute away from that solar array deployment. And what you're seeing on your screen there is an inside view of those solar panels folded up before they're deployed on Dragon. We're just about 30 seconds away from the start of that deployment. Now, deploying the panels does take about a minute, so we do wait for the hinges to lock out on the panels before we confirm solar array deployment for Dragon.
This is Dragon CC on countdown 1. Dragon's propulsion system has successfully primed, and all thrusters report ready for firing.
And there is the start of the solar array deployment. Again, this will take about a minute to complete. And we are looking at the back side of the panels, which is why you see some of that harnessing there, but the solar cells are actually on the other side of the panel. Those solar arrays are looking great. Should be locking out here shortly. And we've got full solar array deployment. Dragon is now officially on its way to the space station. When Dragon arrives in a couple of days, the spacecraft and the space station will establish direct communications link. Then Dragon will slowly approach, pausing at several checkpoints to ensure everything is still going as expected. Eventually, Dragon will be close enough for the astronauts on board the space station to capture Dragon. Then ground communications will be sent from Mission Control in Houston for the station's arm to rotate and install it onto the bottom of the station's Harmony module. Dragon will remain at the space station for about 4 weeks, and then the spacecraft will return to Earth with research and return cargo. So just to recap our mission today, we had a great liftoff this morning. We've had a successful stage separation. We brought back that first stage to our drone ship, Of Course I Still Love You, for the 39th booster landing for SpaceX. And we dropped Dragon off into its targeted orbit and deployed those solar arrays, allowing Dragon to head off to the International Space Station. Dragon's arrival, capture, and installation to the station will be streamed live starting on May 5th at 5 a.m. Eastern Time on NASA TV. Dragon will spend about 4 weeks attached to the space station before returning to Earth with cargo and research. Follow NASA and SpaceX on social media for ongoing mission updates. Thanks to NASA, the range, the FAA, and all of you, the viewers. Until next time, may the 4th be with you.